Hello everyone, in this video I'm going to explain rate of change. What do you mean by rate of change? It means d by dt. So the differentiation with respect to the time. Remember this function of one variable. Let us we see this question. It is in future in mathematics book. This is the question, okay? Now he said the area. He talked about area of circle. Remember the formula of area of circle. The area of circle is by r squared. What are the givens of this question? dA by dt. Increases, it means positive. So the dA by dt, it is 6 feet squared per hour. So what do we need? We need dr by dt, the rate of increasing of the radius. So this is the required. When the area, so the given is the area is 9, when the area is 9 feet squared. Now, we differentiate both sides. So we have here the area equals by r squared. Differentiate both sides with respect to time. Remember, this is a function of one variable. A is the area, r is the radius, so it is a function of one variable. So differentiate both sides. When we differentiate, we write dA by dt equals by is constant. The derivative of r squared, the power comes down, minus 1 from the power, dr by dt. Now, what do we have from the given? Already, we have dA by dt, so this is given. We need dr by dt, so this is the required, but we don't have the radius. But from the given, the area equals 9. From the area equal 9, we can get the radius. So the area equals by r squared, so equal 9. From this, we say r squared equals 9 over pi. Take square root of both sides, so r equals 3 over square root of pi. Now we do substitution. dA by dt equals 6. By multiply 2r. r is 3 over square root of pi. Multiply dr by dt, this is the required. Simplify. 3 multiplied by 2 equals 6. So divided both sides by 6, so this equals 1. You can simplify this to get dr by dt. When you simplify, it becomes a square root of pi over pi. This is the rate of increasing of the radius. The radius is unit of length. So we write feet per hour. In this question, he said a tank of water in the shape of cone. So this is the cone. Now, what are the givens of this one? So, the cone is leaking water at a constant rate, feet cubed. So, this is the volume. So, the given is that the volume of water decreases at this rate. Decreases, it's better to say it's negative. So, the given is that dV by dt equals negative 2 feet cubed per second. The base radius of the tank, so this is the base radius of the tank, is 7 feet. And the height is 14. So this is the height. It is constant, 7 and 14. At what rate the depth? So we need dH by dt. So this is the required. So when h equals 6, then we need a relation between the volume and the height, only the height. What is the relation? The volume of the cone equals the third base area by r squared multiply height. Now we talk about h. So we need a relation between r and h. We need to write r in terms of h. This relation from the figure, you can see, we can take this right-angled triangle. So this angle denoted by theta. In the small triangle, we can use tan theta. So in this, we say tan theta equals opposite over adjacent equals r over h. This is in the smaller triangle. In the bigger triangle, the opposite is 7 and the adjacent is 14. So it is 7 over 14. We need h, so we need to write r in terms of h. We do cross multiplication, so r equals 7 over 14h divided by 7. To simplify, it's a half h. So this is the relation between r and h. Now we do substitution in the given. So v equals 1/3 by, replace r by its value, which is half h squared multiply h. Simplify, so half squared quarter, 4 times 3, 12, so it's 1 over 12 by h squared times h cubed. So this is the relation between the volume and height. It is a function of one variable. Now we can differentiate with respect to the time. So differentiate both sides with respect to the time. Now it's 1 over 12 by constant, 3 comes down, minus 1 from the power, multiply the derivative of h, dh by dt. Now we do substitution. dv by dt, it's negative 2. So this is negative 2. Simplify, 3 divided by 3, 1, 12 divided by 3 equals 4. So it's 1 over 4 when we simplify. By h squared, h equals 6. So it is 6 squared. Multiply dh by dt, the required. 6 squared is 36, so negative 2 equals 36 divided by 4 by dh by dt. 36 divided by 4 equal 9. So negative 2 equals 9 by dh by dt. From this we can say dh by dt equals negative 2 over 9 pi. Negative, it means decreasing. So the height decreases the depth, or the depth decreases with rate 2 over 9 by feet per second. In that question, he said semi-cubical water tank. So this is a cube, okay? All the sides are equal, but he said it holds water which is being pumped in at rate. So this is the rate of increasing of volume. So the volume of water increases at this rate. So the given is that dv by dt equals to meter cubed per hour. Find the rate at which the depth, so this is the height increases. So we need dh by dt of water. Now what is the relation? The volume of cube is side times side times side, so it's L cubed. Volume of water inside that cube is 5 times 5 times h. So it means v equals 25h. This is a relation, function of one variable. V equals 25h. We differentiate both sides with respect to time. So dv by dt equals 25 dh by dt. The required is dh by dt, and the dv by dt is given. So 2 equals 25 dh by dt. From this, it's easy to say dh by dt equals 2 divided by 25. It is the height. The height here, it's in meter. So it's meter per hour. Volume of cube increasing at rate. So the given is that dv by dt equals 600 cubic inch per minute. Find the rate of a change of surface area. So the required is dA by dt. When the length of the edge, denoted by L, 10. So all the sides are equal. What is the relation between the volume and the length of side? The volume of cube equals L cubed. When we differentiate both sides with respect to time, so dv by dt equals 3L squared dL by dt. We have the volume dv by dt and we have L, so we can get dL by dt. Substitute. So 600 equals 3 multiply 10 squared dL by dt. 10 squared 100, 3 times 100, 300. So 600 equals 300 dL by dt. Divide both sides by 300 to simplify. So from this one we can get dL by dt. 600 divided by 300 equals 2. Of course, it's inch per meter, but the required is dA by dt. What is the relation between the surface area or the total surface area of the cube? The cube has 6 faces. The area of each one face is L squared, so it is 6L squared. So the area, the total area of the cube is 6L squared. Now we differentiate both sides with respect to time because the required is dA by dt. So dA by dt equals 6 multiply. The differentiation of L squared, it's 2L dL by dt. We do substitution. 6 times 2, 12. And L equals 10. And dL by dt, it's 2. We use the calculator to get this answer. 2 times 12, 24 times 10, 240. It is area. So it's inch squared per minute. A ladder like this. This is a ladder. Okay, 15 meter long. So the length is 15 meter. Okay. The base, well, we don't have any variables, so let the base denoted by x, and this is the height denoted by y. So I said the base of ladder is pulled away, so x increases. So the given is that dx by dt, moving away at rate 5. If the base is 12, so x equals 12 meter. Okay? And the top of the ladder is 9, so y equals 9 from the ground. How fast is the top? So we need dy by dt moving away. Now we need this one. Now. So. Okay, what is the relation between the variables x and y? This is a right angle triangle. The hypotenuse is 15. So the relation that join the two variables is Pythagoras. So we write x squared plus y squared equals 15 squared. Now we differentiate both sides with respect to the time. So 2x dx by dt plus 2y dy by dt, differentiation of 15 squared is 0. What are the givens? The given everything we have here. So 2 multiply x, x is 12. Multiply dx by dt, it's 5. Plus 2 times y, y is 9. Multiply dy by dt, the required, equals 0. Simplify. 2 times 5, 10, times 12, 120. 2 times 9, 18. dy by dt equals 0. Shift 120 to the other side. So 18 dy by dt equals negative 120. So dy by dt equals 120 over 18 in simplest form. It is approximately negative 6.7. So y, the top of the ladder, he said y, so the top decreases because it's negative, decreases with rate 6.7. What is the unit here? Meter per second. In this question, talk about the surface area of cylinder. The cylinder contains curved area and the total area. What is the total area? Curved area plus 2 times base area. So the total area of cylinder denoted by A, which is the curved area 2 by RH plus 1 base times 2. So it's 2 by r squared. This is the surface area. Now, he said the surface area of cylinder increasing. So we have dA by dt equals 18 centimeter squared per. If the height, so this is here, the cylinder, and this is the height. If the height and the diameter, so this is the diameter, are equal, so the height equals the diameter and diameter equals the 2r, so the height equals the 2r. So this is a very important given. H equals the 2r. What is the rate of increasing of radius? So the required dr by dt. Oh, we need r, we don't need h. When the radius equals 6. Then we need a relation join between a and r only. Then we do substitution. So we need to cancel h. So replace h by 2r. Then the area of that cylinder equals 2 by r multiply 2r multiply 2 by r squared. Simplify before to do anything. 2 times 2, it's 4. By r times r squared plus 2 by r squared. Or we can add them because they are like terms. 2 plus 4 equals 6. So the area equals 6 by r squared. This is a function of one variable. Now what do? We differentiate both sides with respect to the time. So dA by dt equals 6 by constant. Differentiation of r squared, it's 2r dr by dt. We need dr by dt. dA by dt is given, so it's 18. 6 by multiply 2r. r is 6, so dr by dt. We simplify. 2 times 6 equals 12. 12 times 6 equals 72. So 18 equals 72 by dr by dt. From this we can simplify to get dr by dt. It's 18 over 72 by. Simplify. Divided by 18. 1 divided by 18, 4. It's 18 over 72, it's a quarter. Yeah. So the answer in simplest form of dr by, it's 1 over 4 by. It is r. So it is here. Oh, we have one mistake here. Because it said 18 by. So the surface area, it is not only 18, it's 18 by. So one mistake here. It is not only 18, it's 18 by. So we replace a by 18. Yes, so this is 18 by. So just we write here 18 by. So it's 18 by. We cancel by with by. So the answer is 1 over 4. So the final answer is 1 over 4. It is dr, so it is centimeter per second. In that example, talk about sphere. So this is a sphere. So I said if the radius, so this is the radius here, increasing at rate. So the given is that dr by dt equals 5. So this is a sphere. So this is r. So it's like this. This is r, the radius of a sphere. Increasing at the rate 5. Find the rate of a change of volume. So we need dV by dt. When the diameter, oh, this is the diameter. The diameter, it's 2 radii. So when the diameter equals 30 centimeter, it means 2r equals 30 centimeter. It means r equals 15 centimeter. So the required is that dV by dt when r equals 15. What is the rule of the volume of sphere? Volume equals 4/3 by r cubed. Differentiate both sides with respect to time. So dV by dt equals 4/3 by constant. The derivative of r cubed is 3r squared dr by dt. Simplify. How to simplify? We cancel this 3 with this 3. So dV by dt equals 4 by r squared dr by dt. What is the required dV by dt? So 4 by r equals 15, but it is squared, take care. Multiply dr by dt, which is 5. Now we use the calculator to get this answer. So we write here 4 multiply 15 squared multiply 5. The answer is 450. So the answer is 4500 by, it is volume. So we write centimeter cubed per second. I hope you understand this lesson. Thank you.